Hello, my name is Caden Hernandez, and this is my extra credit video for my biology class, Biology 2 for science majors. Today I'll be talking over a few things in order to meet the 7-minute mark for my extra credit. And unfortunately, I don't really have much of a game show, but I do have a brilliant mind that's really good at expanding a lot of things. So we're gonna let my brain fire for a couple minutes and see if all these ADHDs have something to say. Firstly, I wanted to talk about succession. So in order for us to even have life on Earth or life on soil, we need levels of succession. The primary level of succession is life beginning terrestrially from rock. And the reason why is because the distinction between primary and secondary succession is soil. Starting off with no soil means you're starting off primarily, which means you'd have to have lichen, mosses, and other bacteria and water to weather and break down rocks into soil. This, along with their cyclical deaths, create biomass, which is better for the soil to develop. So that's why we have primary succession. And the consequence of that is secondary succession, when we start with only soil. Examples include forest fires and or clear cutting. When we break down all the living things and just leave bare soil there, the succession that will conclude is secondary succession, because you'll already have the base soil with micronutrients and bacteria within it to feed grasses, to feed trees, and to feed bushes. So one of the biggest distinctions on life on Earth is soil development, or succession in general. Primary succession can be concluded towards islands. Islands like the Hawaii Islands, most of them were created through volcanoes. And volcanoes secrete rock hard rock. And the only way for it to develop into soil is through lichen, moss, and all this bacteria and such. Along with that, countless amounts of rain to break down all the soil. It's quite cool, actually. But moving on to that, you could also say, well, the presence of animals in these certain environments can affect them too. Like if you look at Yellowstone, they had a whole keystone animal thing with the wolves. And the reason why the wolves were important was because the wolves providing hunting grounds for many of the deer. And now that the deer were gone, that means there was less competition for all of the other plants or all the elk. And because less deer were grazing on the grass, that allowed much more bunnies and other things to hide amongst the grass that was now gone, or that was now present. But when you look at how succession fits into what kind of landscapes it makes or what kind of environments it makes, you understand that like these animals that are present in these landscapes all have a different purpose. The woodlands would have more wolves and larger terrestrial life like brown bears, while like large savannas would have zebras and grazers and such. But a cool, interesting fact is, all of them need to feed on something. All of them need to water themselves. And I think like 2%, was it saying? 2% of our Earth is covered by fresh water. The rest of it is salt water. But fresh water can be divvied up into a couple of different things. And if you look over here, you have a lake coming down, and you also have this pond over here. But you can't really see the end of it. And that's the difference between the two different types of fresh waters. You have oligotrophic water streams, and you also have eutrophic water streams. And the difference between the two is oligotrophic is clear. You can see straight down to the bottom, while eutrophic is murky. And you might be saying, well, murky means less life. No, quite the opposite, actually. How the teacher, Miss Struble, described it was eutrophic is like the jungle. You have life everywhere, but it competes for space. You look at the Amazon jungle, there is a lot of terrestrial living life. There's a lot of plants, there's trees, And their issues aren't with water. Their issues are with space. How much space can they take up? How much sun can they gain? And this doesn't affect much, but when you look at oligotrophic lakes, you have a lot of space that isn't used. But why? And it's mostly because of nutrient availability. It is a desert. So when aquatic microorganisms try to live there, it's quite hard for them because they don't have what's necessary for them to live there. The equivalent of actual deserts having water. Cool little tidbit about those is most deserts are developed through the 30-30 line on our planet. So the 30-30 latitude lines on our planet is roughly where the cycling of the Coriolis effect and the wind trade winds that we have going on come down with hot, dry water, like hot, dry air. And because hot, dry air comes down on that 30-30 line, many of the environments that live there are very dry, are very hot, and become deserts. So you look at the Mongolian desert, or you look all the way down, you get to see the presence of why it's so the way it is. And it's quite cool because if you take it in contrast to an oligotrophic lake, it's clear. You can see all the way down, and it's barren of much life. And the same thing goes with an actual desert. It's very clear to see through the entire horizon, and the entire horizon doesn't have much life to look at. But when you look at a lot of the lakes people like to go into, they enjoy going into clear lakes and not eutrophic lakes. But when it comes to life on land, people like the trees. Not many people like the barren sands. So it's a cool little thing to think about. I wanted to talk about a lot more, like leaf structures and how we have dicots and monocots. Along with that, I wanted to talk over R and K selected species. You know, R being super fast development because they want a lot of babies, and and S selected. And S selected species being the types to take care of their young, like us humans. But unfortunately, I didn't have that much time. And sometimes, even in life, you don't have much time. But the only thing you can do is learn everything you want to learn and enjoy everything there is to see. Even if it's a eutrophic lake that you can't see the bottom of. But you just gotta enjoy it. So, I will submit this extra credit video, mostly out of a whim, but even more so because I enjoy talking. And one of the biggest points is that I really enjoy learning about our environment and learning about sciences in general. And I hope many more people that decide to watch this video, because I'll post it on more than just a Canvas submission page, take a second to understand that, you know, life has a lot of beautiful things, but it has every opportunity for you to learn. And every opportunity to view a lot of things that you can learn about. Godspeed.